Hello, this is the first video in a multi-video series on building services using http4s. This is video part 1. In this video, we will be checking out the Hello World project or project template from the http4s library. We'll be talking about what exactly http4s is, some of its background, and then the organization of the Hello World project that they provide, breaking down the structure, their usage of tagless, their tests, and how endpoints are structured. In subsequent videos, we will actually take this project and then repurpose it for our own, where we build a recipe server built on top of Quill, Flyaway, Docker, Postgres, and Circle. And what we'll do is have two endpoints, one where we persist and can create and persist recipes with instructions, and another endpoint where we can retrieve recipes. We'll do this using TDD, and we'll also add some functionality at the end where we do minimal versioning of entities. Let's say there are two users and you have user 1, user 2, second user comes in, makes a change to the model that you had, having some sort of feedback to the user kind of indicating the problem and allowing the client to then handle that. That will be how we wrap up this series. Let's go ahead and get started. So what exactly is http4s? http4s is a framework for building web services on top of Scala, embracing the functional aspects of Scala built on top of cat's effect, built on FS2, which is a streaming I/O library, and also having a type model around requests, responses, headers, etc. We won't be using all the bells and whistles that you get in this library, and I won't be going over the documentation in this library. What we'll do instead is go through the Hello World. A lot of this you can kind of come in and check out on your own. There's a lot of very good documentation here on the different components of this library, just like most web frameworks. For our purposes, we'll just use the skeleton project here. But we'll go back for a second and look at FS2. So FS2 is a streaming I/O library for Scala. I'd highly recommend checking this project out. Like I said earlier in the video, we won't be using the bells and whistles here, so don't really worry about that. If you find this library interesting, I'd highly recommend checking them out. So let's go ahead and get started. And what we'll do is under the documentation, start with the just quick start project. I'll be checking this out into a folder called recipes, recipe server. So I have a terminal open. In this terminal, I'll go ahead and check this out into a workspace. And then go ahead and provide metadata to actually create this project. We'll call this recipe server. We'll do, and you can, if you want to follow along, these can be changed. I kind of use this is usually the organization I use for my personal work. And then we'll change the package here. And again, you can change this to whatever you want. If you want to follow along, you can just go ahead and just copy this. We'll use Scala 2.13 and then SPT 1.3. And we're not actually going to use the native image functionality of the Graal JVM. Don't really need to worry about that for this video. It's just an alternative JVM to the hotspot JVM get by default when using the official JDK. And I talked about Circle. I mentioned Circle earlier in the video. Circle is a serialization, deserialization library. You can think of it as the Scala equivalent of Jackson. It's more idiomatic in nature, or more Scala-esque, if you want to think of it like that. And we'll be using Logback as our log provider. So the project has been checked out and set up here. So we'll go ahead and set this up, open this up in our IDE. For this video, I'll be using IntelliJ. If you don't use IntelliJ, you can also follow along using Visual Studio Code and using the Metals plugin for Scala. So I'll go ahead and open up my IDE. We've now opened up the project. We're going to go ahead and move the import process into the background. So while that's happening, we can kind of just browse project structure. But this is a standard Scala project. Build SVT. And we have some dependencies here corresponding to the dependencies we chose in setup. We have a source directory with tests and logback configuration, as well as code for our entry point to the app, our server, our routes, 2 domain entities, and we'll look at that later on in this video. So let's go ahead and get started, and we'll look at the main app and kind of see where it starts. So this is our main application, our entry point to our app. It extends the IO app. IO app is a type provided by IO app is a data type provided by the cat effects library. IO app provides an API around interacting with IO operations, where our application is expected to do some sort of IO operation and then exit with some sort of defined exit code. As you can see here, our IO operation is this recipe server, and then we're going to exit with an exit code of success. And I guess in the real world, if we wanted to change this, we could have some sort of logic that can kind of handle other cases. Like if we're unable to, for example, connect to our database, maybe you want to have a different exit code. So let's go ahead and look at recipe server. Recipe server is wrapping this for comprehension. And in this for comprehension, what we're doing is defining this Blaze client builder. The Blaze client builder is returning a stream of type F, client F. So the tag is actually defined up here as IO, and then it's specifically a concurrent effect. And so as a result, are the types that we use to model these operations are decoupled. So as opposed to hard coding IO through our application or futures or any other monadic wrappers, they're decoupled. So whatever we want to use, we just define this here at the entry point to our app. So that'll be known as F. In this instance, these are concurrent effects. I won't be going into a lot of detail. Cat's effect has great documentation on them, and honestly, I'm still learning them. And so I would highly recommend checking out the cat effects project and looking at these different effects that are provided. But just know the effect here in this context is a concurrent effect. So from here, once we've actually unwrapped the stream, we have this client of F and client of F being an IO. We have these two assignments of our hello world and jokes algorithm. Now, this application has two endpoints, one which is the standard hello world that you find in a lot of web services, and then also a slightly more complex example, and both of these examples are trivial at the end of the day, but slightly more complex where we're actually dealing with an interaction with an external service, and that's using this joke client. As you can see, we're passing that as a dependency. Once we've defined these inputs, we then pass these into our app, into our routes, and then we actually build our HTTP app. These routes you can think of as controllers. If you're working in a Spring Boot application or a Rails application, usually you have the controllers, repositories, and then potentially the service layer. I've worked in code where you have those three layers, and then even further differentiation between DAOs and repositories. In this project, we'll be kind of working kind of within the boundaries of what's prescribed here, where we have routes, and then we have dependencies. For our purposes, once we actually start building out our app, we're going to introduce a repository layer to function as an interface to our data store. And again, as you see, we're passing in that F type, so there's no reference to a specific data type or monad. So let's go back, and we'll come back in here in a second. From here, we've defined the HTTP app. Then from there, we actually build our final HTTP app. And then from here, we actually serve our server. And this is kind of models most web frameworks at the end of the day. Build up a server, bind it to some port on a host, depending on where you want to bind it to, and then serve. At the end of all this, we have an exit code that's then used here to actually terminate our app, or just to return at the end of the application's execution. So let's go. We can look at the routes, or we can look at the these dependencies. So we'll look at the routes and see what we're trying to do, and then we'll actually look at how these dependencies are used. So we have two routes: hello world and joke route. Hello world is defined here. Here's where we define our HTTP routes. So we do pattern matching. And if you don't have a functional programming background, just think of if statements on steroids, and then on top of even more steroids and even more steroids. Provides an incredibly flexible interface for performing complex conditional logic, and then also ad hoc on-the-fly transformations of data. So here we're going to do pattern match. Case the route is a get, and the input is to the root/hello/name as an input argument or path parameter route. Then from here, we actually then return our route and define the behavior of how we actually handle that request and how we handle that response. So as you can see here, the response is defined as an OK of greeting, where we have this hello method on our hello world dependency, where we're processing an input and then returning back a greeting. As you see, we're wrapping that greeting is in an OK, and that OK status type is then evaluated to this response, which is then returned back to the user. So kind of the same thing as most web frameworks, or I say all web frameworks, requests and responses. We just have this functional abstraction around how we define the routes. So in this case, we define a get. If we wanted to do a post or a put, would still be the same thing. You see here I'm changing it to post. Not going to do that because we do have tests and I don't want to break those tests. But let's go ahead and look at what exactly hello world is and what name is. So name is a algebraic data type, or a case class, or class, or an object, depending on what you want to call it. Scala objects are also their own distinct thing. You could just think of these as case classes. You can also think of these as record types in Java 14, which handles a lot of the boilerplate around things such as setters, getters, toString methods, and other things like that. Or if you're not working in a modern Java code base, you use something like Lombok. But case classes provide a lot of APIs for easily or interacting with objects in an immutable way with a fluent API. So once we've defined this input as a type name, we then pass this to our dependency here, hello world, and then we call it hello algebra. This is a term I've seen used when defining these tagless traits. But hello has an input of hello world name, and then it returns f greeting. So here we have our impl down here, and the impl is taking our input, and then we're returning a greeting. As you can see, there's no reference to a specific type. It's all done through generics. So we'll go back to our routes here. And actually, before we leave here, the other thing to notice here is I covered the data type, the name data type. There's also greeting data type here. As you can see, greeting. We're returning back a string. We also have an object for our hello world greeting that defines the encoding logic, where we define how our data is serialized. So we're going to serialize the greeting in the form of message, and then the greeting value greeting, which is defined here. So the JSON response would be message. And we can see that also in the tests. So I'm going to peek at those real quick, and then we'll come back to them later. But right here, we'll see that we want to do an actual request against an endpoint, hello world, and we verify that response returns back a message based on our input. So we'll look at this. We'll look at this a little bit later in this video. So let's go back. The other route is the jokes route, where jokes has a dependency on this jokes type. And here, same thing as down here. We do a pattern match on these on the routes where we define a route of get root / joke, and then from there, based on this joke type, we have an API that returns a joke wrapped in an F or type F. Within this for comp, we have joke unwrapped, and then that is then passed to this OK data type to then form our actual response, where we say that we're wrapping the underlying data type or underlying payload, JSON, whatever you want to call it, as an OK. We could change this to other things if we wanted to do different requests, for example, or another response code. So bad request, bad gateway, let's see. Or unauthorized, but for our purposes, we'll leave this as in the original code. And the only reason that this works is because we have implicit operations around, or implicit conversions around how these things are properly serialized or deserialized. So those are defined back here. Actually, those are defined within joke, but we can see here how these are used, where we actually define how jokes are encoded and decoded. And then same thing to the hello world. Joke is a trait with one method get, which returns jokes wrapped in an F or F joke. The implementation down here, where we have an anonymous definition of joke that's returned in this impl method that expects a client, and that client is used to as an HTTP client. So you could think of this as Apache HTTP or Spring REST client. This client is used to actually make a request against ICANN has dat joke, and then based on this response, we have an API around actually serving the response object mapped to a joke to the consumer of this API here, and that consumer is defined here within our jokes route response. So we've covered the routes, the two services here. You can think of these as services: the Hello World algebra and our jokes service or jokes algebra, and then our main app, our server, and I think routes. So let's go ahead and look at our tests and see what is provided out of the box. So the testing library is using specs2 specification, where we define our tests in the form of specifications, which I really like. I try not to look at tests as in the traditional sense of tests, and I hear phrases like test plans, but the idea is that you're expressing your application behavior in the form of specifications. So here we have this context of our hello world, where we're defining expected scenarios or permutations within this hello world context. In the later videos in this video series, we're going to revisit how this testing is designed. For the purposes of this video, I'm just going to cover the tests that are here, what they're doing, and how we're going to use them in the future. We have two tests. One where we're verifying that the hello world, or we're verifying the hello world object of hello world API returns back 200s, and also properly returns back the input that we expect. So these methods are defined here, and as you can see, we have a match result. You can think it's kind of the same in all libraries. You have some sort of concept of a match, and then some corresponding type. So we then have both these methods that interact with the same value, which is the response against our server, which is defined here. And then that here, and that server responds to requests defined here. So and the last bit, to make sure that this is expressed, this is wrapped in a type IO, and then we go ahead and run the IO in unsafe manner here. And since this is testing, that's okay. And we get back an actual response. And that response is then used down here where we verify it's the response status and then also the underlying data, where we map it to a string and then verify it in JSON form. In later versions of this video, like I said, we're going to be changing things up. We'll actually wrap these to corresponding types. That way we have a more fluent API or more Scala-esque API around interacting with our objects. And then from there, we're going to go ahead and kind of decouple the request from the response and the server from the request and response. That's it for the first part of this video series. Please stay tuned for additional videos. The next video will be discussing what we're going to be building and the technologies that we'll be using. And then we'll be talking about how we want to build a service in a testable and maintainable way. So once you hand this code off to someone else, you have tests as specifications that express what your service should be doing and ensuring the service is working as advertised.